Alright, today we're going to be looking at the alternating series error and really know what it means and understand how it is used. So here's a practice problem, and it's how many terms of the sum of n equals 1 to infinity of -1 to the n plus 1 over n squared do you need to sum in order for your approximation to be accurate to the nearest 1 over 50? So first step is obviously just to list out the terms. So first term is going to be 1, then -1/4 because you plug in 2, then 1/9 and so forth. So when we're finding this approximation, to find the amount of terms, we need to understand the alternating series error. And to get a better understanding of this, we're going to look at the partial sums in a graph. So let me take out the graph. So if you look at this graph here, we have sum of 1, sum of 2 terms, sum of 3 terms, sum of 4 terms on the x-axis, and then the values of that on the y-axis. So sum of 1 is just 1. Sum of 2 is just 1 minus 1/4, which is 3/4. And then the sum of 3 is just 1 minus 1/4 plus 1/9, which is 31 over 36. And then it keeps going, keeps going. Now, if you look at the characteristics of this graph, you see it can be alternating along this arbitrary line that we set up. Now, this line represents the actual convergence of the sum if we went to infinity. So, and then if you take a look, the distance from 1 to the convergence, the actual convergence, is your actual error. So, now, there's another key characteristic. From 1 to the next sum, which is 3/4, we notice that this is much greater than your actual error. So we can, and then if we look at the next one, same thing happens. This distance is the actual error, and the distance from the sum of 3 to the sum of 2 is much greater than the distance from sum of 2 to the actual convergence, which is your actual error. And so let's take a look at the beginning. So we look at 1, and if we subtract 1 minus 1/3, this is your distance from here to here, we get 1/4, which is kind of ironic because that's our next term. Same thing happens here. If you subtract 3/4 minus 31 over 36, you will get 1/9, which is your next term again. So we can say that by partial sums, the first neglected term is your error for the partial sum. So every partial sum, the next term would be your error. So if we take a look back at this long series and we say 1 over 50, we know that 1 over 50 is less than 1 over 49, but greater than 1 over 64. So if we take a look at this now, we notice that 1 over 50, and it's right here, it's in between here, right? So we can see that if the error, we know that this error must be less than or equal to 1 over 64, this error right here. So we can say that to find to the nearest 1 over 50, we need 1, 2, 3, 4, 5, 6, 7 terms. And that is your answer, and that is how you do alternating series and really the understanding of it fully. Now if you want more videos, just go on Cowboys.